introduce ourselves first. My name is Fatin Zulaikha binti Fauzhi.
And my name is Nur Irsyada binti Shamsudin.
My name is Fatin Nashuha binti Nadzri.
My name is Nur Maisarah binti Abdul Aziz.
And my name is Fatin Nashuha binti Jeffri.
Alright, so basically for this topic, there will be 6 parts that we are going to discuss. So I will explain more about the coverage of themes and also the scientific key concept. How about you guys?
I will discuss on the number and arrangement of the topic.
Okay, so for my part, I will discuss more on learning outcome and also learning objective.
Ooh, good choice, Shada. As for me, I will explain about the common experiments for every topic. How about you, Nashuha?
For me, I will explain about the misconception for every topic.
Nice.
Excellent. So without further ado, let's start our discussion now.
Let's
Okay,
go.
let's go.
Ta-da-da! Part 1, coverage of themes. So in the first part of this presentation, we are going to see the comparison of themes between KBSM and also KSSM. To make it easier for everyone to see the comparison between coverage of themes in KBSM and also coverage of themes in KSSM, I have put all the themes into a table. So actually the table is divided into 2 parts. So the first part you can only see the themes until theme 3, and you can see the rest in the second part. So for comparison between the coverage of themes in KBSM and KSSM, we are going to see the difference in 4 different contexts. The first context is the number of themes covered in both KBSM and also KSSM. The second one is the change of chapter covered for each themes. The third one is the change of the theme title, and the fourth one is the change of chapter's title and also chapter's content. So as you can see here, on the left side of the table is the for KBSM, and the right side of the table is for KSSM. So we are going to see the first content, which is the number of themes covered in both KBSM and KSSM. I'm not sure if you have noticed this, but if you have taken a look on the full themes of KBSM and KSSM, you can notice that there is a difference in the change of number of themes. So for KBSM, the number of themes is 6, and while for KSSM, the number have been reduced to only 4 themes. Okay, so I think the reduction of numbers in the themes is good because they have already sorted the chapters in KSSM into related themes so that it is easier to be reviewed, and students and teachers can relate it more better than in KBSM. And then the second context is the change of chapter covered. So let's take a look on the example here in theme 1 for both KBSM and also KSSM. You can see that the numbers of chapters that have been covered for each theme has changed because there is a lesser theme now in KSSM, so they need to cover more chapters in each theme. So for theme 1 in KBSM, there is only 1 chapter covered, while in theme 1 of KSSM, they need to cover 3 themes. Okay, right. So the third context is the change of the theme titles. So as you can see here, so let's take a look on the second part of this. So as you can see here, the theme 2, which is maintenance and continuity of life, has become the title theme for theme 1 in KSSM. Okay, so it has changed. So theme 2 in KBSM has changed to theme 1 in KSSM. So they maintain this theme title, but they have also changed um, the theme title in the next part. So we are going to see the example later on. And then the fourth context is that the change of chapter title and also context. So if you have already seen all the full chapters for KBSM and also KSSM, there is a change of theme titles where in KBSM, for instance, you can see that the chapter 1 is microorganisms and their effects of living things. But for chapter 1 in KSSM, the title only microorganisms. But despite the change of the themes, they also have changed in the content of each themes, where in KSSM, the content is more updated and easier to be understand. Alright, moving on to the second part of the table. So you can see it very clearly, as I mentioned before, that there are 6 teams in KBSM, while in KSSM they only cover for 4 teams only. And if you can also notice that there is a difference in the total chapters covered, both in KBSM and also KSSM, where in KSSM they cover 8 chapters, but in KSSM they cover 9 chapters. So for more in-depth discussion for all the themes in KSSM, so this will be discussed in the next part.
Hi everyone, now I will continue this presentation. So during my session, we will take a look regarding to the number and arrangement of the topics for subject General Science Form 5. So during my explanation, I will make some comparison between KBSM and KSSM textbook. From here, we can identify the improvement that has been made for KSSM syllabus, either it is beneficial for the student or not. Okay. So there are some aspects that I will explain today. So let's start now. Alright, there are 6 aspects that I will explain today. Number 1 is the number of theme. Next, the scope and sequences of the topics. And at this point, I will show you the details for each chapter regarding to their topic and also the subtopic. And I will show you for both textbook, KBSM and KSSM. And also, we will talk about the balance of depth and breadth and the level of difficulty, presence of multiple perspective, and last but not least is ways to make the team selection better. So let's move on to the first aspect, which is number of team. Okay, for the number of team, I'm pretty sure that my groupmate before this has covered and explained regarding to the coverage of the team. So just to recall back from the previous slide, basically there are different number of team between KBSM and KSSM. Okay, so for KBSM, it consists of 6 teams, while for KSSM, it consists of 4 teams only. Okay, so for KBSM, the teams are the first one, as you can see in the slide, which is the human and also diversity of living things. Second, maintenance and continuity of life, balance and environment arrangement, matter in nature, force and movement, and lastly, the development of technology and industry on society. So for KSSM, there are only 4 themes, which are the maintenance and continuity of life, exploration of elements in nature, energy and sustainability of life, and lastly, the Earth and space exploration. So from here, you can see that KSSM has less number of team, right? So after this, we will see what are the differences regarding to the topic and also the subtopic for each team. Okay, the next aspect that I will explain is about the scope and sequences of the topic. So we will take a look for each term for KBSM and KSSM. So we will start with KBSM first. The first theme is Human and Diversity of Living Things, which is consists of one chapter only, Chapter 1, Microorganisms and their Effect of Living Things. So for KSSM, the first theme is Maintenance and Continuity of Life, which consists of three chapters, Chapter 1, Chapter 2, Chapter 3. So for Chapter 2, it is actually the combination of Chapter 6 from KBSM syllabus. That's why the name of the chapter is Nutrition and Food Technology, because they combine Chapter 2 from KBSM, which is Nutrition, and Chapter 6 from KBSM, which is about the food technology. The last chapter for the first theme of KSSM is Chapter 3, the Sustainability of the Environment. Okay, we will move on to the second theme for KBSM, which is the Maintenance and Continuity of Life. It is consists of one chapter only, which is Chapter 2, Nutrition and Food Expenditure. For KSSM, the second theme is Exploration of Elements in Nature. It consists of three chapters, which is Chapter 4, 5 and 6. And for your information, Chapter 4 and Chapter 6 are the new chapter that do not have include in the KBSM textbook. This is the new chapter that I mentioned just now, which is Chapter 6, Electrochemistry. Let's move on to the next theme for KBSM, which is Balance and Environment Arrangement. It consists of one chapter, which is Chapter 3, Preservation and Conservation of the Environment. And for KSSM, the third theme is Energy and Sustainability of Life. That consists of two chapters, Chapter 7, Light and Optics, and Chapter 8, Force and Pressure. For Chapter 7, it also a new chapter that do not have in KBSM syllabus. Alright, the fourth theme for KBSM is a Matter in Nature, which consists of one chapter, which is Chapter 4, Carbon Compound. And for KSSM, the last theme is Earth and Space Exploration, that consists of only one chapter, which is last chapter, Chapter 9, Space and Technology. Okay, next, so the fifth theme for KBSM is Force and Movement, which consists of one chapter also, Chapter 5, Movement. But for your information, for KSSM syllabus, they do not have a subtopic 5.1 until subtopic 5.4. They only focus on the concept of pressure of fluid. And has been made as one chapter, which is Chapter 8, Pressure of Fluid, as I shown you just now. The last theme for KBSM is Theme 6, the Development of Technology and Industry of the Society, which consists of three different chapters, which is Chapter 6, that has been combined with Chapter 2 for the KSSM syllabus, and then the Chapter 7, Synthetic Materials in the Industry, and the last chapter is Chapter 8, Electronic and Information. So I hope you guys can see some differences between the KBSM and also KSSM syllabus, okay, regarding to their subtopic and also themes. Okay, we will move on to the next aspect. The next concept is about the balance of depth and breadth. Okay, what do you know or understand about depth and breadth? Okay, I will explain to you the meaning of depth and breadth. For depth, it refers to the extent to which specific topics are focused upon, amplified, and explored. And for breadth, it refers to the full span of knowledge of a subject, and not only the knowledge but also the skills. So there are some differences between KSSM and KBSM syllabus about the types of activity and tasks in the textbook. For KBSM, the activity only asks the student to observe and answer the question. Also, the activity involving the discussion among the student. And for KSSM, the activity have made some improvement, which is the activities such as project, multimedia, debate and simulation, and also inquiry activities. And talking about the breadth, both syllabus had covered most of the basic science concept that students should know, which is for me, it is good enough for them as a non-science stream student. Alright, the next aspect is level of difficulty. So for me, both syllabus have an appropriate level of difficulty, and if I can rate the level of difficulty, it can be said at a medium level. The reason why I say that it at the medium level is because all the topics are suitable for non-science stream student, and also content explaining the basic knowledge of science. For me, all the content in the textbook or the syllabus are suitable for them, because if we want to compare with the syllabus for science stream student, it is more complex. Okay. The next reason is because the content are suitable for student cognitive level, and also all the experiment and activities in the textbook are simple and easy to conduct in the classroom. In science class, experiment and activities are important to help them to gain some basic knowledge of laboratory skills, and also help them to enhance their understanding about science concept. That's why for me all the experiment activities in the textbook are good. For present of multiple perspective, what do you understand about multiple perspective? Based on my understanding, it refers to the student learning perspective. As we know, there are various types of student learning perspective regarding to the certain topic. Before that, what is the meaning of perspective? Perspective refers to the way of thinking and understanding about certain things or topic. So there are two important keywords here, which are the way of thinking and also understanding. As we know, every student have their own capability and types of learning style. For example, auditory, visual, kinesthetic, reading or writing. So based on this situation, the student need different types of activities and also approaches in the classroom that will help them to have a good understanding regarding to the lesson. So based on my reading, for KSSM syllabus, there is an implementation of some activities in the classroom that include the 21st century skills and also the usage of technology. So the example of the activities that have in the KSSM textbook is inquiry activity, innovation activity, discussion, debate simulation, project and also multimedia. Actually, for KBSM textbook also have a few types of activity, but it all limited regarding to the discussion and also the answering the question only. They do not have the inquiry activity, project activity and also the multimedia activity. Okay, the next slide I will show you the example of the activity that I took from both textbook. These are the example of activities that I took from the textbook. So for KBSM, it only have activity regarding to the discussion, observation and collecting data. For me, it's already good, but we need more interesting activities for the student to enhance their understanding, plus to create a fun learning environment in science class. As we know, science subject have various of activity that can be done in the classroom. Okay, so for KSSM, they have 6 types of activities such as inquiry, simulation, project, as I mentioned before. For the first example for KSSM, it is the example for the inquiry activity, and the second one is about the project activity, and the last one is discussion among the student. And I think KSSM activity can help students to increase their understanding for the topic they learn. So the last aspect that I will explain today is the way to make the team selection better. Based on our discussion, we agree that the latest syllabus for general science subject is much more advanced compared to the previous syllabus, which is KBSM, because of the implementation of STEM, high order thinking skills question, and also the 21st century skills. But we notice that the latest syllabus still lack of development of essential skill. So that's why we suggest to include the development of essential skill. For me, the example of essential skill needed by the student are such as competitive skills, work and study skill, information skills, and also the physical skills. Based on my reading, the reason why our students still lack of skills is because our education system are more focused to academic achievement, where the student just need to read, to memorize the information. Their aim just to pass the exam or test only, but they do not realize that they already lack of development of essential skill, which is also important for their future. So, for me, it is important to implement this kind of skills in our syllabus and curriculum so that the student not only gain knowledge but also can develop their basic skills. So, one of the initiatives that we can try to implement this essential skill for students is to prepare more activities that can be conducted in the classroom based on the suitable essential skill. By doing these activities in the classroom, they indirectly can develop the skills. Teacher also play an important role to make sure that this initiative is success. I think that's the only suggestion that can be improved because another example are already good and very suitable for the student. Alright, I think that's all from me. Thank you for listening and let's continue with the next presenter.
Hello everyone! For this part, I am going to share with you about learning objective and also learning outcomes. So basically in this video, I am going to cover some area which is the first one, introduction of learning objective. Second, step in writing learning objective. And then I am going to show you learning objective that have in science textbook form 5. The fourth is introduction of learning outcomes. The fifth one is steps in writing learning outcomes. And the sixth one is I am going to show to all of you learning outcome that have in textbook science form 5. So let's move to learning objective. Okay, introduction of learning objective. In 2020, Sperrio stated that learning objectives is the instructor's aim for creating and teaching their course. It usually viewed from the instructor's perspective, meaning learning objective represent what does the instructors want student to accomplish. Hence, the learning objective for science curriculum for students to accomplish represent the aim for Ministry of Education Malaysia. According to the Content Organization of Curriculum Specification, Science Form 5, science curriculum is organized around teams, and each teams consists of various learning areas, and each of that consists of learning objective. For your information, one learning objective might have one or more learning outcomes. Okay, here I am going to show you steps in writing learning objective. Learning objective always start with the phrase at the end of this topic or at the end of this chapter. Student will be able to then connect with the action which communicate the performance by the learner. As example, at the end of this chapter, student will be able to 1.1 understand the importance of having transport system in some multicellular organism. So these are the main component of learning objective. A is stand for audience. Who does outcome pertain to? For example, in the textbook Science Form 5, the audience of the textbook is for the student. B is refer to behavior. What do you expect student to learn or student to know? So, behavior we can refer to Bloom taxonomy. As we all know, Bloom taxonomy consists of 6 levels. The lowest level of Bloom taxonomy is remember, followed by understand, apply, analyze, evaluate, and the highest level in Bloom taxonomy is create. Okay, the next one is C. C is stand for condition. Under what condition will learning be demonstrated? D is refer to degree. How much will be accomplished? These are examples of learning objectives that I took from textbook Science Form 5. Students will be able to apply 5 major behavioral theories in the creation of a health performance plan. Student is referred to A, which is audience, will be able to apply. To apply is referred to B, which is behavior. 5 major behavioral theories is referred to C, which is condition. In the creation of health performance plan, that is referred to D, which is degree. So next, let's take a look learning outcomes. Learning outcome. Learning outcome contrasts to the learning objective. Sperry stated that learning outcomes are the answer to those questions. They are specific, measurable knowledge and skills that the learner will gain by taking this course. Texas Higher Education Coordinating Board 2015 defines student learning outcomes as what students are able to demonstrate in terms of knowledge, skills, and attitude upon complete of a program. In developing the learning outcomes, knowledgeable professionals in the field will answer to a few questions. First, what would students be able to upon graduating? Second, what knowledge, skills, or ability should students demonstrate? Third one is, how will students be able to demonstrate what they learn? If learning outcomes have been created well, students have much better chances to success in learn and to perform skills and tasks. So how to create good learning outcomes? A strong learning outcomes should follow SMART checklist. What is SMART checklist? Okay, now let's take a look. SMART. S is referred to specific. Learning outcome focus on a specific category of student learning. M is referred to measurable. Learning outcome produced from assessment, actionable data that can be collected to measure student learning. A, attainable, is realistic, neither out of reach nor below standard performance. R is relevant. Answer this. Will it drive the student forward? Does it align with the mission? So if yes, it is good learning outcome. And the last one is timely. Learning outcome should establish a time frame and describe activities that serve as benchmark towards achievement. Okay, here in the table, you can see difference between weak outcomes and also strong outcomes. Strong outcomes, outcome words are sharp, clear, and specific. As example, it stated the word write, calculate, describe, analyze, and make it clear to what students should know and be able to do at the end of the subtopic. Strong outcomes also demonstrated varying level of thought. This can be referred on Bloom taxonomy hierarchy. I will show you the example of good learning outcome that I took from Science Form 5 textbook. Okay, the third one is strong outcomes refer to knowledgeable or skills specific to the discipline, and strong outcome also readily observable, demonstrable, and measurable. Okay, now let's analyze either the learning outcome inside the textbook is good or not. Let's check it by referring to SMART checklist technique. Okay, here I put two learning outcome that I took from Science textbook chapter 6, which is come from the topic food technology, subtopic 6.1. First one is the first one of learning outcome is give examples of good made from a combination of natural and synthetic rubber. The second learning outcome is compare and contrast synthetic rubber with natural rubber. Okay, based on the first learning outcome, is it have a good outcome verbs that are short, clear or specific? The answer is yes, because it state and use the word give example and students are clear with the instruction. And for the second one, compare and contrast also outcome verb that are specific, clear and short. Okay, second one. As we can see, learning outcome 1 give example of good made from a combination of natural and synthetic rubber. We can see they are leaking of measurable thing, which is M, measurable. The learning outcome should put measurable so that student can know how many that they need to remember. Okay, such as it should be like this. Give 3 examples of good made from a combination of natural and synthetic rubber, like that. For the second one, compare and contrast synthetic rubber with natural rubber. So it can it also lack of measurable things. Okay, 2 are these learning outcomes demonstrate varying level of thought? The answer is yes. Give in Bloom taxonomy is in the remember what we call remember state, which is the lowest one, while compare and contrast is at analyze state. So that we can see it demonstrate varying level of thought. And the third one, both learning outcome is not readily observable, demonstrable, and measurable. Here are learning objective and learning outcomes that I compile it into the table from chapter 1 until chapter 6. Learning objective for subtopic 1.1 is understanding the classification of microorganisms. The learning outcomes, a student is able to list the characteristic of various types of microorganisms, classify microorganisms, bacteria, fungi. Third one is describe the characteristic of each group. For chapter 2, evaluating. Learning objective for subtopic 2.1 is evaluating the importance of taking good nutrition and practicing good eating habit. A student, for learning outcomes, a student is able to explain the factor that affect total calories, relate health problem to nutrition, justify the importance, like that. I list it until chapter 6. You can take a look by yourself if you want to see more, because I am not going to analyze one by one because it will take a very long time. And what I just want to say is, okay, roughly we can see that learning objective and learning outcome is good, but it can be improved to be more sharp and accurate. Okay, here are my opinion about learning outcome and learning objective. Student performance can be enhanced when learning objective align with the instruction and assessment. There was one research regarding to this topic. Researchers investigate students use the perception of learning objective in an undergraduate science course at public research university. Even though this research have been made to undergraduate students, but it can be as what we call as a rujukan. In this exploratory study, students completed 2 open-ended assignments regarding learning objective and they analyzed the content of their answer. They found that students used learning objective in ways that reflected the recommendation of past and present instructors, suggesting that students are receptive to instructions on how to use learning objective. So, students generally found learning objective to be useful because the objective helped them to narrow their focus and organize their studying, suggesting that students may need additional help from instructors in order to self-direct their learning. Learning outcome make students study on their own, especially to prepare themselves to face examination and come to the class well prepared. Learning goal gives students a way to think and talk about what they learn. They make it easier for students to know what they know and give students a language to communicate what they know to others. So, it is important that textbook need to have strong learning objective and learning outcome. I didn't say that learning outcome and learning objective that exists in a textbook is not good. Existing learning outcomes can be improved so that they can help students to learn easily and they can make learning outcome as their benchmark to study.
Ta-da-dang! So now back to me again. Alright, so we're now in the 4th part of this presentation. So we're going to talk about this scientific key concept. So in this part, we are going to take a look on some of the scientific key concepts that make it as the fundamental for each chapters in this syllabus. So let's go. So the first chapter is microorganisms. When talking about microorganisms, we can already imagine all the small things, small living things, such as viruses, bacteria. So let's take a look on the key concept in this chapter. Alright, so let's take a look on the first key concept in this chapter, which is microorganism. So as you can read here, the word microorganisms is defined as the minute organisms that cannot be seen with the naked eye. So in my opinion, the definition of key concept should be straightforward so that students can understand the word easily. So here, the word minute organisms, in my opinion, should be changed or replaced into another word such as microscopic organisms, because with the word minute here, minute organisms, a student have to find another way to define the word minute organism. So the next key concept in this chapter is the classes of microorganisms. So here are some of the pictures for the 5 classes of organisms. So can you guys guess which is who? Right, never mind, let me just give you the answer. So the first picture here is fungi. Alright, the second picture here is algae, the third picture here is protozoa, the fourth one is bacteria, and the last one is viruses. So these are all the terms associated with microorganisms. So with all these terms, I think that the conformity or the alignment with the curriculum aims is achieved because first, the word microorganisms already defined not only the type of organisms that they are going to learn in this chapter, but it defines and also represent the whole chapter. The second one is the appropriate level of difficulty. For me, the word microorganisms here, the level of difficulty is a little bit high for students who are not familiar with sciences subject. But for the other terms such as the fungi, algae, and also protozoa, bacteria, and viruses, the appropriate level of difficulty is suitable with the level that they are learning. And then the third one is the development of cognitive skills. So here, students should be able to reach the first and also second level of the Bloom taxonomy, which is to remember and also understand, where they need to remember and understand the concept and definition of microorganisms and also the classes of microorganisms. Alright, so the next term is normal flora. So here normal flora refers to the microorganisms found in organisms including humans and animals which do not cause illness. So in much simpler word, normal flora can also be defined as the site where microorganisms can live and do not cause harm to living things. So here, in my opinion, students should be able to not only reach the first and second level of Bloom taxonomy, which is remember and understand, but students should be able to reach the last level of the Bloom taxonomy, which is create, where by understanding the normal flora concept, students can, if they were given task to like design normal flora for certain living things, they be able to design it according to the organisms that they are given. The next term is vaccine. So this is something that we usually hear nowadays, go get vaccine, go register for vaccine. But do you know what is the meaning of vaccine? So here it is given that vaccine is a substance that is used to stimulate the production of antibodies, provide immunity against one or several diseases, prepared from the causative agent of a disease, its products, or a synthetic substitute treated to act as an antigen without inducing the disease. So in much simpler way, vaccine helps to stimulate the production of antibodies so that we can build immunity in our body to fight against disease. So mind you that vaccine does not cure the disease, it just helps us to protect, to build immunity against the disease. So now that we are talking about vaccine, I would like to remind you guys to go register for vaccine, which will be open on 25th May, if I'm not mistaken. So if there is an empty slot for areas that are available, so go get your vaccine now, okay? Other than that, we have the term or key concept, which is ecoenzyme. So have you guys heard about ecoenzyme before? So here, ecoenzyme can be defined as a natural product obtained from the fermentation of agricultural waste such as fruit or vegetable waste. So here you can see the picture where they convert the fruit peel or the vegetable waste into natural cleaning product. So here, it promotes the fostering the positive values and also attitude, where it encourages students to use natural cleaning product made from vegetable waste or food waste, so that it could help to reduce toxic substances or waste in the environment. So not only it introduces a new concept for students, but it also help to encourage students to learn about some positive values. Finally, we have come to the last few key concepts for this chapter. So as you can see here, I have 4 key concepts, which are aseptic, sterilization, antiseptic, and also disinfectant. So by reading the terms or the key concept, we can already guess that all these terms are related to cleaning techniques or way to remove or kills bacteria or microorganisms. So by learning all these key concepts, students should be able to reach up until level 3 of Bloom taxonomy, which is applied, where students can implement what they have learned in all these cleaning techniques to solve problems in their daily life according to the situation. So basically, in conclusion, for the first chapter, is that the terms is appropriate and also aligned with the curriculum aims, and they are also inclusion. They included suggested reference to help students facilitate self-directed learning, where they include the QR codes uh, at each chapter, so students can scan the QR code and learn more about the chapter. Now moving on to chapter 2, which is nutrition and food technology. So mind you that we are still under the same theme as chapter 1. So let's take a look on the key concept in chapter 2. Alright, so the first term for this chapter is balanced diet. So when talking about food production and nutrition, balanced diet is a word or a term that we will usually hear, because here balanced diet is defined as the diet that includes all the classes of food in the right quantity according to the individual's body requirement. So here this picture could summarize what is balanced diet is, because where in a meal you should have all the nutritions to help with the growth of your body. So here, in my opinion, students should be able to reach at least the first level of Bloom taxonomy, which is remember, because by remembering this term, student can relate with the whole chapter, which is food nutrition and also food production. So now that we know what balanced diet is, we could easily relate what all these three terms are in this chapter. So the first one, we have malnutrition, which is a condition that results from eating a diet which does not supply a healthy amount of one or more nutrient. And then the second one is Pinggan Sihat Malaysia, the concept Pinggan Sihat Malaysia, where it promotes eat 3 main healthy meals a day, and the concept of suku-suku separuh. The concept of suku-suku separuh is suku nasi, suku protein, and also separuh fruits and or vegetables. And the third term is the calorific value. So it is also known as energy value, which is the amount of energy released from the complete oxidation or combustion of 1 gram of that food. So by learning all these three concepts, students can actually understand further what this chapter is all about. So I think it is matched or aligned with the curriculum aims to teach students what will happen if they don't eat balanced diet, which is they will suffer from malnutrition, and also the importance of having calorific value, to calculate the calorific value so that they know the intake of value that they have daily. So with this, students should be able to reach the second and also third level of Bloom taxonomy, which they should already can remember, understand, and also apply all these three concepts in their daily life. Now moving on to the next terms, we have first the bomb calorimeter. So bomb calorimeter is actually an apparatus to measure calorific value of food. So this is what we use to measure it. And then the next term, we have macronutrients and also micronutrients. But here in this chapter, they focus on the macronutrients and micronutrients for plants only, which is so the macronutrients mean elements or minerals required by plants in large quantities, while micronutrients are elements or minerals required by plants in small quantities. So here, in my opinion, the definition is very straightforward and easy to understand. So the level of difficulty is appropriate to student level, because they already in Form 5 and they probably have heard about these terms before. Alright, so now we have come to the last key concept for chapter 2. So here we have nitrogen cycle. So nitrogen cycle is defined as the natural cycle that recycles nitrogen between plants and animals and the atmosphere, soil and also water. So here, in my opinion, the accuracy and also the relevancy of the concept is accurate and correct because this is also what the science stream student who takes biology learn in their syllabus. So and then the next one is that the definition for nitrogen cycle is appropriate to the level of difficulty for Form 5 students because by this rate they should be able to understand a complex process. So not only that the definition is much simpler, is simple to understand, they also provide this diagram of nitrogen cycle in the textbook to help students understand more how this process happens. And then by learning this term, students should be able to reach level up until level 4 and also level 6 of the Bloom taxonomy, where they should be able to analyze what is nitrogen cycle and also create nitrogen cycle in different land size. Chapter 3, sustainability of the environment. So this is the last chapter for the first theme. So let's take a look on the key concept in this chapter. So the first key concept in this chapter is upcycle. So this is upcycle is a recycling process to produce new products of higher values than the original product. So what they usually do during upcycle is that they will take any old products from any source and then turn it into high-end products so that they can sell it at a higher values than the original product. So for example, as you can see in this picture is an upcycle product, so where they turn the front part of the car into a chair. So for me, this is a good initiative because not only they introduce the new concept to the students, but they also encourage students with positive value and attitude so that students can learn about recycling more with this. Alright, moving on to the next term, which is product life cycle. So product life cycle is defined as the amount of time a product goes from being introduced in the market until it's taken off the shelf. So basically product life cycle is about how long a product can sustain in the market. So this is important concept for this chapter because students can understand the sustainability when producing a product. So under the term product life cycles, students can also learn about carbon footprint, the concept of carbon footprint, and also the concept of carbon handprint. So by here, students can reach the fourth level of Bloom taxonomy, which is analyzing, where students should be able to differentiate between the concept of carbon footprint and also carbon handprint. So what is the difference between these two concepts? So carbon footprint is actually the negative impact of environmental sustainability of a product, while carbon handprint is the positive effect of a product, of production of product. Alright, so the next concept are cradle to cradle versus cradle to grave life cycle of a product. So this is the continuation concept for life cycle of a product. So let's take a look on the definition for both of the concepts. So the first concept is cradle to cradle life cycle, which is defined as a design philosophy that aims to eliminate waste from the production, use and disposal of a product, while cradle to grave life cycle is a design philosophy that considers the environmental effects of a product all the way from manufacture to disposal. So how does this differ? So the first concept is about to eliminate waste, and then the second concept is that it considers the environmental effects of production of a product. So for much clearer information, so let's take a look on some of these diagrams. So alright, so this is how cradle to cradle works, where the aims to eliminate waste from each step when producing a product, and then we have cradle to cradle-to-grave concept where they consider all the environmental risks when producing a product. So for me, the term or the concept cradle-to-cradle and also cradle-to-grave concept uh, is aligned with the curriculum aims, whereby because this chapter is about the sustainability of environment, so all these terms are aligned with the curriculum aims, and it has an appropriate level of difficulty where in my opinion, I think by this time students should be able to understand much uh, harder or much complex concept. And then for the development of cognitive skills, by this time, in my opinion, I believe that students can achieve at least level 4 of the Bloom taxonomy, where they can analyze and also differentiate between these two concepts. Then we have the term microplastic. So microplastics is defined as plastic pieces less than 5 millimeter in length, which can become hazardous if found inside the body of aquatic organisms. So in my opinion, the key concept here, which is microplastic, is defined in a very straightforward and easy to be understood by students. So the level of difficulty here is appropriate with student understanding. The last key concept for this chapter is effective microorganism, or also known as EM. So it is defined as a liquid mixed culture made up of lactic acid bacteria, photosynthesis bacteria, and also yeast. So other than being in a liquid mixed culture like this, so it can also be formed into a ball such as this EM mud balls. So actually the definition for effective microorganism is not included in the textbook, so I think this is something that should be taken into account, so that they will include it in the next textbook. But they include the example for the EM, which is the EM mud balls that is used to treat contaminated water. Moving on to the next chapter, which is chapter 4, the rate of reaction. So as we can read from the title, so this chapter is all about how a reactant will react and produce a product. So let's take a look on the key concept available in this chapter. The first key concept is rate of reaction. So this is also the definition for the chapter title. So rate of reaction is defined as the change in the quantity of reactant on product per unit of time. So when writing the definition, students should write about the change in quantity and also per unit of time, because that is what rate is about. So in rate of reaction, we are going to use this formula, which is the division formula, to calculate the rate of reaction. In my opinion, the key concept rate of reaction is aligned with the curriculum aims, where it defines this whole chapter, what the whole chapter is about. And then the accuracy and also the relevancy of concept is also true, because this is also what the science stream student learn in biology and also physics maybe. So this is the same definition and formula that they use. While the appropriate level of difficulty, I think the term and is very straightforward, and it is easy to be understood by student. While for the development of cognitive skills, the rate of reaction should make student able to reach up until the level 3 of the Bloom taxonomy, which is remember, understand, and apply. So they need to remember the definition of this term, understand how the rate of reaction works by looking at the formula, and last but not least, apply this when solving the calculation problem. When learning about the rate of reaction, students should also know all these three terms, which are the reactant, product, and also catalyst. So these three terms are substances that is involved during a reaction process. So by learning all these three terms, students actually have achieved the aim for this chapter, because with these three terms, students can understand more how a reaction can occur, how a reaction works and also occur. So all these three, how these three themes work during a reaction can, so it can summarize into this diagram. So as you can see here, we have the starting materials, which is the reactant, and then we have the catalyst, and also lastly we have the product. So this diagram show how these three substances work during a reaction. In my opinion, this diagram need to be included in the textbook so that students can understand the concept better. Then we have the terms such as the average rate of reaction and also the rate of reaction at specific time. So this is kind of like sub topic for the rate of reactions, where the average rate of reaction is defined as the average value for the rate of reaction that occurs in specific time interval, and rate of reaction at specific time is the instantaneous rate of reaction, which is a reaction that occur at any particular point of time or specific instant. So by learning these two terms, so students should be able to reach the level 3 and 4 of the Bloom taxonomy, which is apply and also analyze the concept of average rate of reaction and also rate of reaction at specific time. Okay, because so they can use this when they solve the problems during the calculation. Last but not least, for the scientific key concept of this chapter is the Haber process. So Haber process is defined as a process that combines nitrogen from the air with hydrogen derived mainly from natural gas, which is methane, into ammonia. So I think it's a very direct definition that can easily be understood by students. So because they already understand how nitrogen is formed from the nitrogen cycle from the previous chapter, so they can understand more how nitrogen is processed into ammonia. So by learning this term and also concept, the accuracy and also relevancy of concept is correct, because it is also similar to what the science stream student learn in chemistry, if I'm not mistaken, and also in biology. So, and also for the development of cognitive skills, students should be able to reach the analyzing level, where students should be able to differentiate how each step in the Haber process works. So this is the last scientific key concept for this chapter. Moving on to chapter 5, carbon compounds. So let's take a look on what are the scientific key concepts in this chapter. So the first key concept for this chapter is carbon compounds. So carbon compounds is defined as compound which contains the element carbon C, hence why it is named as carbon compound. So in my opinion, by learning the definition of carbon compounds, it has reached the aims for the chapter, because it defines not only this term, but it also defines the title of this chapter. So under carbon compounds, students will find terms such as organic carbon compounds and also inorganic carbon compounds, where it is the classes of carbon compounds. So here students can reach the fourth level of the Bloom taxonomy, where they can differentiate between organic carbon compounds and also inorganic carbon compounds. Right. Next, we have the carbon cycle. So carbon cycle is defined as process of how carbon elements are recycled through the formation or decomposition of carbon compounds in living things and organic substances in the environment. So in much simpler way, carbon cycle is about how carbon circulate in the environment and also in the atmosphere. So by learning this term and also concept, students has reached the aim in understanding how carbon cycle works. So for me, the accuracy and also the relevancy of concept for carbon cycle is true, because this is also similar to what the science stream students learn in biology. And also for the appropriate level of difficulty, in terms of the definition, the definition is very easy and straightforward to be understood by students. Now that students have learned about what carbon compounds are, carbon cycles, so students should also be able to understand what hydrocarbons mean and the classes of hydrocarbon compounds, where hydrocarbons are divided into saturated hydrocarbons and also unsaturated hydrocarbons. And then we have the alternative energy sources and also renewable energy sources. So this term actually students have learned about this in Form 3, Chapter 6, which is electricity and magnetism, where they learn about the definition for both concept and also the example. So here, in my opinion, students have already can reach up until the level 4 of Bloom taxonomy, where they are not only able to remember, understand, and apply this concept, where they can also analyze, which means they can differentiate what is alternative energy sources and also what is renewable energy sources. Next one, we have the saturated fats versus unsaturated fats. So this one is different from the saturated and unsaturated hydrocarbons. So when they learn about this chapter, students should be able to also reach level 4 of the Bloom taxonomy, where they should be able to differentiate between saturated and unsaturated hydrocarbons and also saturated fats and unsaturated fats. So the appropriate level of difficulty is appropriate for the Form 5 students because both of the concepts are easy to understand. Coming up to these last few terms, scientific key concept for this chapter. So we have the variety of process under this chapter. So here we have 4 different terms, which are esterification, hydrolysis, emulsification, and also saponification. So by learning all these terms, students can understand how this process occur and takes place and what it is for. And then students should be able to reach a few level of the Bloom taxonomy Bloom taxonomy level, which are remember, understand, apply, and also analyze how this process works and also when can they apply it. So in terms of alignment with the curriculum aims, I think with the definition and also showing how this process works, the aims for this chapter is achieved, where students can understand how this process works. 6. Electrochemistry. First key concept is electrochemistry, which is defined as a study in chemistry of the relationship between electrical and also chemical phenomena. So this define the whole concept for this chapter. So next we have the electrochemical cell. So electrochemical cell is a device that can generate electrical energy from the chemical reactions occurring in it, or use the electrical energy supplied to it to facilitate chemical reactions in it. So this is how the electrochemical cell looks like. So we will going to learn more about this in the next point. The electrochemical cells, students will learn about 2 electrochemical cells. So the first one is electrolytic cell, where electric current will flow through an electrolyte to produce a chemical reaction. So in this electrolytic cell, electrical energy is converted to chemical energy through the process of electrolysis. So this diagram shows how the electrolytic cell is set up. And then the next one, we have the chemical cell, where chemical changes occur in the cell will produce electric current, and chemical energy is converted to electrical energy in the cell. So this is how the setup of chemical cell. So by learning these 2 terms, students will learn 2 different concepts of electrochemical cell. And here, students will be able to reach up until level 4 of Bloom taxonomy, where they can able to differentiate the concept of electrolytic cell and also chemical cell. We will also encounter terms as electrolysis, which is a process to convert electrical energy to chemical energy. So under electrolysis, so this is the setup of electrolysis. So we will find terms, a few terms such as anode, which is the electrode connected to the positive terminal of electrical source, and then cathode, cation, anion, and also electrolyte. So here students should be able to at least remember all these terms and also the position of all these terms in the setup of electrolysis. Right, next we have the term electrolyte and also non-electrolyte. So electrolyte is defined as substances in molten or aqueous state which allow electric current to flow through them and undergo changes. Right, so while non-electrolytes, it is the opposite concept for electrolytes. So here when we have two different concepts that is opposite, the level of Bloom taxonomy that is being tested here is the analyzation, where students can make comparison between electrolyte and also non-electrolyte. So these are the examples of electrolyte and also non-electrolytes that students will found when they make experiments. So this is the last key concept for this chapter, which is electrochemical series. So I think this is something that is not foreign to all of us because we also learn this in lower secondary school. So electrochemical series is defined as a series of metals that are arranged according to the tendency of the atom to donate electrons. So here we have the list of cation and anion and also an ion that are arranged according to the tendency to donate their electrons. So usually students will make acronym to remember this. So if you guys remember the acronym that you made during your high school, so you can share also with the class. Next one is chapter 7, light and optics. So this chapter falls under the third theme for KBSM. So let's take a look on all the scientific key concepts. So the first key concept for this chapter is about the type of lenses. So here students will learn about two types of lenses, which are convex lens and also concave lens. So convex lens is lens that converge rays of light that convey parallel to its principal axis, while concave lens is lens that spread out light rays that have been refracted to it. So for concave lens, the lens is dispersed after it arrive at the focal point. So from the term, actually we can also know how what is the shape of the lens. So we're going to take a look on the next diagram to find out what is the shape for each diagram. So these are the two types of lenses, their shape. So can you guess which is which? Alright, so on the left side is the convex lens, and while on the right side it is the concave lens. So for you, for students to easily remember the shape for each lens, so we have here concave lens mean cave. Cave mean it went to inside. Right? Remember the door of the cave, it's like melengkung ke dalam. So this is how concave lens looks like, and then you will easily remember the convex lens shape. Right, next one we have some of the terms that is included when drawing ray diagrams. So in order for students to understand all these terms, they need to refer to this diagram on the right side of the slide for more understanding. So this one is similar also. Students can find all these the location of all these terms in this diagram. Learning all these terms, students can finally achieve the objective learning for this chapter, where they learn all the terms and also concepts that is relatable to this chapter. And for the development of the cognitive skills, in my opinion, students are able to reach up until the last level of the Bloom taxonomy, which is up until create, because students can after they understand all the concepts and all of the terms, they are able to create these ray diagrams like the one included in this slide. The next chapter is chapter 8, which is force and pressure. So this is the second last chapter for KSSM. So let's take a look on all the scientific concepts in this chapter. For this chapter, students will learn about two main principles, which are Pascal principle and also Bernoulli principle. So let's take a look on the first principle, which is Pascal's principle. So Pascal's principle is defined as the transmission of pressure exerted on a fluid, which is whether liquid or gas, in an enclosed system is uniform throughout the fluid and in all directions. So here, notice that there is an important keyword here, which is enclosed system. So enclosed system is defined as a physical system where matter cannot enter or leave the system. So throughout this chapter, students will also learn about how this principle works, and also some of the examples of each principle. Right, next we have the hydraulic principle, which is a basic principle that is based on Pascal principle. So here we have a diagram that is included in the textbook that shows the operation of hydraulic system, where in hydraulic it has two ends. The first one here we call it as the input end, and this one is the output end. After students have learned and understand about how hydraulic principle works, so they will also learn about the examples for hydraulic principle. So the first one, we have the hydraulic jack system here. So this is how it works. So, and then this is the example of hydraulic jack. And then by this rate, students are able to achieve up until the third level of the Bloom taxonomy, which is apply, where students can apply all these principles in their daily life to solve the problems. In my opinion, even though this chapter is a little bit hard to be understand and also learn, but with the help of diagram and also example for each principle, students will manage to understand it and also apply it in daily life. The accuracy and also the relevancy of concept is true, because this is also what the science stream students learn in physics. So we are finally at the last chapter, which is chapter 9, space and technology. So this chapter falls under the last theme for this syllabus. So let's take a look on some of the key concepts in this chapter. The first, one of the first key concepts that students will learn in this chapter is the type of satellite. So here I have summarized the types of satellite into a diagrams, where we have the high Earth orbit, the low Earth orbit, the geosynchronous orbit, medium Earth orbit, and also the geostationary orbit. So by reading and also understanding the terms and analyzing the location of the satellite, so students will be able to understand and also draw the types of satellites. Next, we have the apogee and also the perigee. So, do you guys know what is apogee and also perigee of a satellite? Don't know? So, let me show the definition to you guys. So, the perigee of a satellite in an elliptical orbit is the position of the satellite, which is the closest from the planet or star encircled by the satellite, while perigee is the opposite concept of perigee, which is the furthest position from the planets or stars encircled by the satellite. So here you can see the position. So by here, students are able to achieve the fourth level and also the third level of Bloom taxonomy, where students are able to differentiate between perigee and also apogee concept of satellite. Next, we have Hohmann transfer orbit. So it is an orbital maneuver that transfers a satellite or spacecraft from one circular orbit to another. So this concept explains how a satellite or spacecraft is transferred from one orbit to another. And then we have the term space junk. So Space junk means the non-functioning satellites use part of ELV satellite debris from collisions between satellites, exhausted rockets, and other waste. So, in much simpler words, space junk is the waste that are available in the space. And the last key concept for this chapter and also for this presentation is zero gravity. So, we usually heard about this term when astronauts went to the moon where there is zero gravity there. So zero gravity means the condition when no significant gravitational force effect is felt, so they can fly and hop all around. In conclusion, for scientific key concept for all the chapters in this syllabus is that most of the key concepts are aligned with the curriculum aims. So by learning all these key concepts, students are able to achieve some of the learning objective for each chapter. And then for the accuracy and also relevancy of the concepts, all the key concepts are accurate and also relevant because this is also what they use to teach for the science stream students. And then the next one for the appropriate level of difficulty. In my opinion, I found that there are some of the scientific concepts that give difficult definition that is hard for students to understand. Um, Next one for the inclusion of suggested reference to facilitate self-directed learning with the help of diagrams, examples, and also QR codes for extra information. Students are able to do their self-directed learning by themselves if they want to gain extra knowledge and also to further understand all the concepts. And last but not least is the development of the cognitive skills. So as I explained for each of the scientific key concepts, the key concepts achieve a certain level of the Bloom taxonomy. So it helps to achieve the curriculum aims. And forgot one. So fostering the values in attitude. So for this, there are some concepts that promotes and also encourage students to practice positive value and attitude in order to help sustain the environment.
Hello, my name is Fatin Nashuha binti Mohd Nadzri, and today, as for my part, I will explain briefly about the common experiments that are included in the Form 5 KBSM Science textbook. Okay, before I start, do you know what is the definition of experiment? Okay, experiment is the scientific procedure undertaken to make a discovery, test a hypothesis, and also to demonstrate a known fact. I want to emphasize experiments are really important in certain subjects, especially in science subject. This is because it can bring so much benefits to the students. The most obvious benefits that the students can get is they can gain more knowledge and understand the subject way better compared to when they just sit in the class and learn the theories and just memorizing the theories, because doing the experiment physically can actually increase their understanding about the subject. So it is important for them to do experiments. Science lab experiments can also promote discovery and learning. For example, if they get the wrong or invalid result during the experiment, they can still try again and they will understand which results that they are supposed to get and understand better. And maybe they can discover new alternatives in order to get the correct results. There are many other benefits of experiment, and as I said earlier, it is very important so that the students can understand the concept better. In the first chapter, There are 3 experiments included in the textbook. The first experiment is under the topic the presence of microorganisms, and this experiment is really simple and suitable for the students to conduct, because the procedure is really straightforward, where they just need to prepare agar, which usually is prepared beforehand by the lab assistants or the teachers themselves, and they just need to stick their hand on the agar under few conditions. After a few days, they can observe and count the number of colonies of bacteria on the agar and just record the data in the table. Really simple, because it is straightforward and the procedure is short and can be understood by the students easily. For the next experiment, experiment 1.2, it is under the topic factors that affect growth of microorganisms. In this topic, there are 5 factors included, which are humidity, light, temperature, pH value, and also nutrients. The experiment is quite long, as you can see, because they need to do the experiment separately for each factors. So maybe the teacher can just divide the students into few groups, and they can just share the results at the end of the experiment, so it can save more of their time. For the first part, the nutrient, they need to compare the number of colonies of bacteria in agar that contain nutrient and also agar that does not contain nutrient. For the humidity factor, they need to compare agar that has water, and another one is a dry agar. The next factor is light. In this case, one of the agar is placed in a dark cupboard where there is no any source of light, and another one is placed at a bright area. For the temperature, they need to place the agars at different temperature and compare the results. The last factor is pH value, where the students need to prepare a few agars with different pH value, and they need to record all the results that they get in the table provided. Experiment 1.3 is conducted by the students after they have learned the concept of antibiotic. Experiment 1.3 is conducted to study the effect of concentration of antibiotic on the growth of bacteria. They need to prepare few concentrations of antibiotics and place them on the agar, and then compare the results after a few days. There is a table provided, as you can see, for them to record the results that they have obtained. In experiment 2.1, the students will conduct this particular experiment after they have learned about the calorific value of food. The aim of this experiment is to estimate the calorific value of several samples of food using a calorimeter. As you can see at the procedure part, they have to set the apparatus accordingly to the procedure, and they have to do the experiment using few samples of food such as groundnuts, bread, and also anchovies. And the result obtained will be recorded in the table provided. Then they will have to answer the questions after they have finished all the experiments and they have obtained the results. In experiment 2.2, the aim of this experiment is to study the effects of macronutrients such as nitrogen, phosphorus, and also potassium deficiency on the plant growth. So they have to prepare 4 types of solution, which is Number one is the normal culture solution, which has all the nutrients. The second one is solution that have no nitrogen. The third one is the solution without phosphorus, and the last one is the culture solution that is lack of potassium. So they have to compare the growth of the plants in these different types of solutions, and as you can see, they have to record the results in the table provided after they have obtained the results. So they also have to answer the questions given after they have finished the experiment. For chapter 3, which is sustainability of the environment, there is no experiments included in the textbook. Experiment 4.1 is conducted to study the effect of temperature of reactants on the rate of reaction. Since the materials used for this experiment is chemicals, so probably the students will conduct this experiment in the chemistry lab, and they will learn about the precaution steps of using the chemicals and the right way to use the apparatus. So I think it is a suitable experiment for them to improve their laboratory skills. And this experiment is quite simple, although they need to use dangerous chemical, but they will gain new experience of handling the chemicals in the lab. Again, the table provided is for the students to record their results after they have finished the experiments. For experiment 4.2, the aim is to study the effect of concentration of reactants on the rate of reaction. So in this case, they will use different concentration of chemicals, which is sodium disulfate solution, and they will react the sodium disulfate solution with other chemicals. Same as other experiment, they will record the results in the table provided, and they have to plot the graph from the table that they have filled in, so that they can see the rate of reaction, the effect of concentration on the rate of reaction more clearly. The aim of experiment 4.3 is to study the effect of size of reactants on the rate of reaction. So in this experiment, the students will use different size of marbles that indicates the size of particles in chemicals or any compounds. The apparatus is needed to be set up according to the procedure as shown. It is a bit complicated, as you can see, but it is actually doable for a Form 5 students to conduct the experiment. So I think it is still suitable for the syllabus. So for the results, they need to record the results in the table as usual, and they need to compare the time taken and the rate of reaction of each size of marbles in under the data analysis. The last factor that affect the rate of reaction is catalyst. So in this experiment 4.4 is to study the effect of presence of catalyst on the rate of reaction. So basically, the students have to set up the apparatus according to the procedure, and they have to do the experiment and in order to obtain the results. After they have obtained the results, the students will answer the data analysis and questions to test their understandings, whether they know or not the real function of catalyst in a reaction. In chapter 5, which is carbon compounds, there is only one experiment included in the textbook. The experiment 5.1 is to produce soap through saponification. Besides learning the concept of this syllabus, I think it is quite interesting for the students to conduct this experiment and make their own soap. So, the procedure, the apparatus setup is a bit complicated, but I think it is doable and still suitable for the syllabus. And by doing this experiment, I think the students will understand more about how the soap is produced. In the 6th chapter, which is electrochemistry, there are 4 experiments in total. The first experiment, which is experiment 6.1, the aim is to study the electrolysis of ionic compounds in solid, molten, and also aqueous states. The experiment is divided into 2 parts, part A and part B. Part A is about the electrolysis of ionic compound in solid and molten states, and part B is electrolysis of ionic compound in aqueous state. So they have to set up the apparatus as shown in the procedure, and they have to conduct the experiment. The observation that they have recorded, they have to state in the table provided, and also they have to answer the questions given at the end of the experiment. The aim of experiment 6.2 is to study the effect of position of ions in the electrochemical series on the tendency of the ion to be discharged at the electrode. In this experiment, as you can see, there is a science info where the students can learn about the test, the specific test for specific gas. So I think it is very convenient for them to have this kind of info in the textbook, because as a science students, they have to know the test, the suitable test for each gases. And as usual, at the end of the experiment, the students have to answer the questions given for them to test their understandings, whether they know or not about the concept of the syllabus. In experiment 6.3, the aim is to study the effect of concentration of ions in electrolytes on the selection of ion to be discharged at the anode. In the experiment, I don't know if you can see the box with a caution sign. It says that the chlorine gas is poisonous. So I think this kind of caution is really effective or really useful for the students in order for them to be aware of the chemicals that they use in the experiment, because in this case chlorine gas is poisonous. So if they do not use the chemicals properly, accidents might happen. So we do not want that to happen. Uh, Again, for the science info provided in the purple box, you can see uh, it is about the test, litmus paper test for acids and alkali. Uh, for the observation, they have to record their observation in the table and also answer the questions for to test their understandings. For the last experiment in chapter 6, uh, which is experiment 6.4, it is conducted to study the effect of the type of electrodes on the selection of ion to be discharged at the electrode. So the students will conduct this experiment after they have learned about the types of electrode, which in this case is cathode and anode. So they will learn about which electrode is negative charge and which is more positively charged. So in this experiment, they will use two types of electrode, which are carbon electrode and also copper electrode. So I think it is a suitable experiment to be conducted by the students in order to improve their understandings about the types of electrodes. For chapter 7, light and optics, there is no experiments included in the textbook. There is also no experiments included for chapter 8, which is force and pressure. In the last chapter, which is chapter 9, space and technology, there is also no experiments included in the textbook. So what I can conclude is that all of the experiments included in the textbook for each chapter is quite suitable. It's still suitable for a Form 5 students to conduct because it is simple. Most of them is simple, but some of them is a bit complicated, especially in the apparatus setup, but they are still doable. And I think some of the chapters that do not have experiments is because the technology in school science labs are limited and there is no suitable technology for them to do specific experiments. So I think to highlight my opinion, experiments are really important, especially for the science students, for them to improve their lab skills so that they can use it. They can use the skills in future maybe, and also they will improve their understandings besides just study and learn the theories themselves. So I think that's all for me. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Nashuha binti Jeffri, and today I will continue and explain more details about the misconception for every topic in science subject for Form 5 students, KSSM. Okay, so we continue. Okay, so first of all, let we discuss what is misconception. Okay, in general, misconceptions are described as an idea that provide an incorrect understanding of such ideas, objects, or events that are constructed based on a person's experience. Okay, in the aspect of education, when teachers provide instruction on concept in various subjects, there are teaching students who already have some pre-instructional knowledge about the topic. Student knowledge, however, can be wrong, illogical, or misinformed. Okay, this wrong understanding are called as misconception. In fact, misconceptions are a normal part of the learning process. We quite naturally form ideas from our everyday experience, but obviously not all the ideas we develop are correct with respect to the most current evidence. Moreover, some concepts in different content areas are simply very difficult to hold. They may be very abstract, counterintuitive, or quite complex. Hence, our understanding of them is flawed. In this way, even adults, including teachers and especially students, can sometimes have misconceptions of materials. Okay, so basically there are 5 types of misconception, which are preconceived notion, non-scientific belief, conceptual misunderstanding, vernacular misconception, and factual misconception. Okay, for firstly, preconceived notion is an idea. Okay, an idea your mind has created from its own prior experience that typically does not bear direct resemblance to the actual experience. Okay, for non-scientific belief, okay, include views learned by students from sources other than scientific education, such as religious or mythical teachings, pseudoscience belief, and superstition. Next, for conceptual misunderstandings, okay, it arises when students are taught scientific information in a way that does not provoke them to confront paradox and conflicts resulting from their own preconceived notions and non-scientific belief. Okay, next, vernacular misconceptions describes the difference in the use of words within the scientific community and its everyday use. Okay, and lastly, for factual misconceptions, it's about when the falsities, okay, when the students often learn at an early age and retain unchallenged into their adulthood. Okay, so next, we will continue to discuss the possible misconception across the topic in science subject for Form 5 students. Okay, for topic 1, which is microorganism. Okay, the first misconception among students that we found, most of them thought that viruses are living organisms. Is this a true statement or not? What do you think? If you think this is true, I believe you also have a misconception regarding this topic. In fact, virus is not a living microorganism. Okay, it is true that virus is under the group of microorganism. However, most viruses do not respond to changes in environment, which is a definitive trait for living organism. Also, viruses can replicate themselves only by infecting a host cell, so they cannot reproduce on their own way. Okay, that is why we conclude that virus is not a living microorganism. Okay, next for topic 2, which is nutrition and food technology. Okay, the popular misconception among students is that they said nitrogen cycle is linear, that all nitrogen atoms go around the cycle step by step. Okay, in this case, students understood that the nitrogen cycle is non-linear. Okay, that some nitrogen atoms might never go to all reservoirs and just go from one to another. Okay, actually, this statement is not true. Okay, where the fact is nitrogen cycle is non-linear. Not every nutrient will go through the cycles in the same path. Okay, the same atom or molecule may be stored for a long time in one stage of a cycle. Cycle between the same two stages or enter every stage. Okay, next we proceed for chapter 3, which is sustainability of the environment. Okay, in this chapter, one of the misconceptions among students is that they thought greenhouse effect is perceived equivalent to a greenhouse. Okay, students are confused and cannot differentiate between the meaning of greenhouse and greenhouse effect. The truth is, greenhouse effect is not same with greenhouse. Okay, greenhouse effect is the way in which heat is trapped close to the surface of the earth by greenhouse gases. These heat trapping gases can be thought of as a blanket wrap around the earth, okay, which keeps it toastier than it would be without them. Okay, greenhouse gases include carbon dioxide, methane, and nitrous oxides. Why? For a greenhouse, okay, a greenhouse is a structure with walls and roof made chiefly on transparent materials such as glass, in which plants requiring regulated climatic conditions are grown. These structures range in size from small shed to industrial-sized buildings. A miniature greenhouse is known as a cold frame. Okay, the interior of a greenhouse exposed to sunlight become significantly warmer than the external temperature, where it protects its content in cold weather. That is greenhouse. Okay, so in conclusion, greenhouse effect is not same with greenhouse. Okay. So we proceed for topic 4, which is rate of reaction. Okay, one of the misconception among students in this topic, where students believe the smaller the surface area, okay, the collision will occur frequently and it will make the rate of reaction to become fast. Okay, is this a true statement? What do you think about this? Actually, in fact, the rate of reaction increase not when surface area are smaller, but it is increased when the surface are also increased. Okay, if we can see from the slide, okay, the picture is from the science textbook for Form 5. Okay, it states that the size of solid reactant is one of the factors affecting the rate of reaction. So, breaking the reactant into smaller pieces will increase the surface and more particles are exposed to the reaction mixture. And this will result in an increased frequency of collision and therefore it will faster the rate of reaction. Okay? Okay, next let's continue with topic 5, which is carbon compound. Okay, in this chapter, students' common mistake is that they thought photosynthesis and respirations are the same process. Are they a same process? Do you agree photosynthesis and plant respiration are the same process? Unfortunately, photosynthesis and respiration are two different processes. Okay, they are not a same process. Okay, I will explain. Okay, photosynthesis is the process by which plants use light energy to convert carbon dioxide and water into sugars. Okay, the sugar produced by photosynthesis can be stored, transported throughout the tree, and convert into energy which is used to power all cellular processes. While for respiration, it occurs when glucose with the sugar produced during photosynthesis, okay, combined with oxygen to produce usable cellular energy. Okay, this energy is used to fuel growth and all of the normal cellular function. Carbon dioxide is a carbon compound which is released into the atmosphere through the respiration of all living things, including animals, plants, and microorganisms. Another misconception among students in this chapter is that students thought the word hydro in the term of hydrocarbon means they contain water. in this situation, we can see that students cannot define correctly the meaning of hydrocarbon in a scientific way. So, in fact, hydrocarbon does not contain water. Okay, hydrocarbons are defined as compounds that contain only carbon and hydrogen atoms. Okay, the word hydro refer to hydrogen. Okay, so from the Form 5 science textbook also we can see that it states that hydrocarbon compounds are organic carbon compound that made up of only carbon and hydrogen element. Okay, therefore, we conclude that hydrocarbon does not contain water. Next, let's proceed with chapter 6, which is electrochemistry. Okay, in this topic, students always thought that the anode is positively charged because it has lost electron. This is one of the common misconceptions among students regarding this chapter. So, in fact, this statement is not true. Okay, actually, anode is not always positive. It is the electrode at which oxidation, where the loss of electrons take place. Negatively charged ion migrate to the anode to lose electrons or get oxidized. The charge on the anode depends on the type of cell. Okay, in electrolytic cell, the anode is positively charged. Okay, this is because the electrode connect to the positive terminal of the battery is where the negatively charged ion go to lost electron, that is to oxidize. So being connected to the positive terminal of the battery makes the anode positive in an electrolytic cell. However, in electrochemical cell, the anode is negatively charged as the negatively charged ion lost their electron to an initially uncharged anode, okay, making it negatively charged. On connecting an external circuit to an electrochemical cell, the electrons flow from the negatively charged anode to the positively charged cathode. So the current flows will be from the cathode to the anode. Next, for the topic 7, which is light and optic. Okay, the misconception that we found among students is they believe that half covering a lens will result in half an image being formed on a screen. Okay, this statement in fact is a bit confusing even for an adult. Okay, therefore, this misconception is very popular among students and they always have a different opinion regarding this misconception. Okay, so actually, the answer is no. Okay, half covering a lens would not result in half an image being formed on a screen. However, it would result of full image with this decreased intensity. When you cover half the lens, you get a fainter image. Effectively, you are cutting out half the light rays, but they still produce an entire image. Okay, so if we can see from the diagram in the slide, okay, that rays from the top and bottom of the tree still pass through the top half of the convex lens to form. However, half of the rays from all parts of the image are blocked so that only half reach the image point, giving only half the intensity of the complete lens. Next, let's continue for topic 8, which is force and pressure. Okay, in this topic, students always misunderstood that the pressure of a fluid in motion is not depend on velocity. This type of misconception shows that students are still confused and cannot fully understand the concept of Bernoulli's principle. So, in fact, okay, the pressure of a fluid in motion is actually depend on velocity. Okay, so let's see the figure 8.10 in the slide. Okay, it shows that the fluid pressure at P1, P2, and P3 are same, because it not flowing where it is at rest position. However, from the figure 8.11 here, we can see that when the fluid starts to flow, the velocity of the fluid at P2 is higher than the velocity of the fluid at P1 and P3. Okay, this shows that the narrower the part of the venturi tube, okay, the lower the pressure in the fluid. From this, we can conclude that when the fluid flows through the narrow part, its velocity increases and the pressure in that region decreases. This is what is stated in Bernoulli's principle. So, last but not least, for topic 9, which is space technology. Okay, one of the misconceptions among students is that many of them thought all satellites are man-made. Are you agree with this statement? In my opinion, okay, many of us also will think the same. If we don't have a good understanding about the concept of space technology, we will also agree that all satellites are man-made. However, in fact, not all satellites are man-made. For our information, a satellite is an object that moves around a larger object. So our Earth is a satellite because it moves around the Sun. The Moon also is a satellite because it moves around the Earth. Earth and the Moon are called as natural satellites. Usually when someone says satellites, they are talking about man-made satellites. Okay, man-made satellites are machines made by people. These machines are launched into space and orbit Earth or another body in space. Okay, so in conclusion, not all satellites are man-made. Okay. So we have already finished discuss all the possible misconception across the topics for Form 5 Science subject KSSM. Next, I would like to give some recommendations, especially for teachers, in order to help prevent and reduce the presence of misconception among students in the classroom. Okay, so firstly, teachers can ask students to write down their pre-existing conceptions of the materials that being covered. By doing this, it can allow teachers to overtly assess students' preconceptions and provide them with an opportunity to see how far their understandings has come after learning the new concept. Okay, next, I also would suggest that teacher can use as frequently as possible a concept of mapping to students because it is easy to use and more reliable than conventional tests. For example, in topic 7, which is light and optic. Okay, teachers can do a mapping and show to students clearly how refraction can occur in lens. Therefore, by doing this, students can understand how the concept of light and optic work. Okay, and lastly, teachers also need to focus on the facts on why right is right before they address a potential misconception in class. Students will be able to understand well and reduce their common mistakes on certain topics when they already know the right fact and the reason of it. Okay, so that's three recommendations from me to reduce the misconception among students in the classroom. So we already finished discuss all the parts for this topic, and we hope all of you can gain something from the discussion just now. That's all from me and my group. And thank you for watching our video presentation, and we hope to see all of you again in the future. Thank you. Assalamualaikum.